Hi, Mr. Richards here. Today's algebra lesson is on differences of squares. Our objectives are to factor binomials that are the difference of squares, and to use the difference of squares to solve equations. As we can see from our key concept box, we have differences of squares, where a squared minus b squared is the product of a plus b squared and a minus b squared. So when we have something like x squared minus 25, that's simply x plus 5, x minus 5. T squared minus 64, think about what 64 is. That's 8 squared. And so we have t plus 8 and t minus 8. And actually that key concept box helps us solve our first polynomial. We can rewrite this m squared minus 64 as m squared minus 8 squared. And so now we do have our a squared minus b squared, which is just a plus b times a minus b. And so what we can do now is say, all right, this here is going to equal m plus 8 times m minus 8. And that's it. That's our factored solution with m squared minus 64. Our next example, we have 16y squared minus 81z squared, and we want to factor this polynomial. Well, what can we do with our 16y squared? We can rewrite that as 4y squared. What about our 81z squared? Well, we can write that as 9z squared. That's in the a squared minus b squared form. So now, to finish up, we could just write this 4y plus 9z times 4y minus 9z. And that's my factored solution. What about 3b cubed minus 27b? Well, here we get to do something special. We get to take out the GCF of these two numbers first. What is the GCF of these two numbers? Well, 3b. If I do that, I'm left with b squared minus 9. And what is b squared minus 9? Well, that's b squared minus 3 squared, as 9 is 3 squared. And now once again I have this in the a squared minus b squared form. So I'm left with the 3b that I originally factored out times b plus 3 times b minus 3. Now with that, could I write this 3b times b minus 3 times b plus 3? Yes, you could. Both of these answers could work. Now it is possible, using this difference of squares method, that we may need to apply this technique more than once to factor completely. So we have y to the fourth minus 625. Let's try to get this in the a squared minus b squared form. This is going to equal y to the fourth we could call y squared squared minus, well, 625, the square root of that would be 25, so 25 squared. Well, this then breaks into y squared plus 25 times y squared minus 25. Now notice how we're not done yet. We can still factor this even more. Now we keep this y squared plus 25 as this technique is called difference of squares, and we cannot factor that out yet. This y squared minus 25, let's rewrite that as y squared minus 25 is 5 squared. So to finish this up, we keep the y squared plus 25, and then our y squared minus 5 squared is y plus 5 times y minus 5. And that is my factored solution. What about 256 minus n to the fourth? Let's start off by writing this in our a squared minus b squared form, which is 16 squared minus n squared squared, which then is 16 plus n squared times 16 minus n squared. And just like in our previous example, we'll keep this 16 plus n squared, but we can rewrite this 16 minus n squared into 4 squared minus n squared, so that this is now 16 plus n squared times 4 plus n times 4 minus n. And this is my factored solution. So now we have factor the polynomial 9x to the fifth minus 36x. In here, we get to factor using different techniques. Let's start off by factoring out the GCF, and our GCF here is 9x. So if we factor out the 9x, what we have left is simply x to the fourth minus 4. As 36x divided by 9x gets us that minus 4. Now I can write this x to the fourth minus 4 into a squared minus b squared form. So this is 9x times the x to the fourth. We could rewrite as x squared squared minus 4 is 2 squared. Now we can rewrite this as x squared minus or plus 2, and then x squared minus 2. And if I look, this 9x, as far as I can take that, x squared plus 2 is as far as I can take that, and I can't apply anything here to x squared minus 2 because I can't take this 2 apart any more than I have. So this is my factored answer, 9x times x squared plus 2 times x squared minus 2. And now we have 6x cubed plus 30x squared minus 24x minus 120. In this example, we can again start by factoring out the GCF. And what is our GCF of all these numbers but 6? So we'll have 6 times x cubed plus 5x squared minus 4x minus 20. Now, let's group the terms with common factors. We'll have 6 times, let's group here, the x cubed minus 4x, and we'll add that to the grouping of 5x squared minus 20. Now we can say, all right, this is going to be 6 times, let's take out an x here from the x cubed minus 4x. This would be x times x squared minus 4 plus, let's factor out a 5 times, again, x squared minus 4. Now, if I regroup this, I'd have 6 times x plus 5 times x squared minus 4. Now, we have the 6 times x plus 5. And the x squared minus 4 I can rewrite as just x squared minus 2 squared. And now I can finish up by going, okay, 6 times x plus 5. The x squared minus 2 squared is just going to be x plus 2 times x minus 2. And that's my solution. 6 times x plus 5 times x plus 2 times x minus 2. A little bit of work goes into solving that type of question. And for our last example, we have in the equation y equals q squared minus 4/25, which is a value of q when y equals 0. Well, let's write this now as q squared minus 4/25 equals y, but y is going to be 0. Now, can I take the square root of 4/25? Sure. I could rewrite this as q squared minus 2/5 squared, and that's going to equal 0. And so now I'll have q plus 2/5 times q minus 2/5. And both of those are going to equal 0. And now using the zero product property, I could write these two equations, q plus 2/5 equals 0, and q minus 2/5 equals 0. And when I subtract 2/5 from both sides of this first equation, I'm left with q equals negative 2/5. And when I add 2/5 to both sides of the equation here, I'm left with q equals a positive 2/5. So my two answers here are q equals 2/5 and q equals negative 2/5. Those are my roots. Now, to answer the test question, we have our choices 2/25, 4/25, 0, and then negative 2/5. Well, the correct answer here is D, negative 2/5, because it is one of the possible values for q. And that is it for this lesson on difference of squares. Good luck.